In this video, we'll be doing an annotation and color coding of the periodic table. You will need a printout of the 2 pages, which we're going to stick together, scissors, glue, pen, pencil, ruler, and about 8 different colored highlighters or crayons. So first, let's carefully cut off the right edge of page 1 and then stick it onto the left margin of page 2. You'll see that the key in the middle shows the atomic number, which gives the number of protons and the number of electrons, and the relative atomic mass, which gives the number of protons plus neutrons, as well as the electronegativity, which gives the tendency of an atom to attract a shared pair of electrons in bonding. Remember that different periodic tables can give these numbers in different positions within each block, so just look at the key each time to show what has been written where. Now, the most important thing to notice is that the periodic table is arranged with the elements in order of increasing atomic number. So for example, boron has an atomic number of 5, carbon 6, nitrogen 7, oxygen 8, and so on. Also remember that the atomic mass can be given as a fraction because it takes into account the relative abundance of each different type of naturally occurring isotope of each element. Look for example at magnesium or copper or chlorine. Now I want to draw your attention to the steps of the periodic table. They start under hydrogen, and this dotted line shows how they go all the way across to boron, and then it starts to step down. This will guide us in the position of the metals on the left side, the non-metals on the right side, and the metalloids along the step. The dotted line isn't usually shown on the periodic table. We've just included it here to help you see that hydrogen falls on the right side of the line because it's actually a non-metal. Let's color code our periodic table before we get further acquainted with the other important features. First up, let's do the non-metal solids. I'm going to use pink. Next, let's do the non-metal gases. I'm going to use orange. You'll see that some of these elements were underlined. That's because they are diatomic molecules. We'll revisit those later on. Next, let's color the 2 elements that are liquids at room temperature. I'm going to use yellow. They are bromine and mercury. Now let's do the metalloids along the step. They are all the elements along the step except for aluminium. I'm going to use purple. Now let's do the active metals. I'm going to use blue. Now let's do the transition metals in the middle. I'm going to use green. Remember, mercury is already colored because it's a liquid, but because of its position, it's also a transition metal. Now let's do the weak metals. They are still on the left side of the step, but they are the closest to it. I'm going to use light blue. Lastly, let's do the inner transition metals. They are otherwise known as the lanthanides and actinides, and from their atomic numbers, you can see that they are supposed to squeeze into this space. But that scale would make it very tricky to print the table on a normal page, so they've been pushed to the bottom. That's okay, because we don't refer to them too often, since most of them are not naturally occurring. Uranium is a notable exception. I'm going to use light green to highlight these inner transition metals. Now that our periodic table is color-coded, let's look at some other important features. The columns of the table are known as groups and are often numbered using Roman numerals. The numbers of the groups tell us about the number of electrons in the outermost energy level of each atom, but more about that in another video. The rows of the table are known as periods and are numbered from 1 to 7 as well. It's easy to remember the C for columns and the G for groups have got a similar shape, as well as the R for rows and the P for periods. The elements in the first group are called the alkali metals, except hydrogen of course, and those in the second group are called the alkaline earth metals. The first and second groups together are called the S block. As we've already mentioned, the transition metals fall in the middle. This is known as the D block. Groups 3 to 6 don't really have other common names, but the elements in group 7 are known as the halogens. It's a particularly interesting group because it includes elements that are gases, liquids, and solids at room temperature. I want to mention the diatomic molecules again. Remember, those are the ones that are underlined. They are the elements that need to exist as two-atomed molecules in order to be stable. You can remember them because they all end in gin: hydrogen, nitrogen, oxygen, and the halogens. The last group are called the noble or inert gases. They already have all the electrons they need to be stable, so they never undergo reactions with other elements. That's the reason why their group number can be given as 0, although on some tables it's given as 8, following the pattern of the other group numbers: 1, 2, 3, 4, 5, 6, 7, 8, or 0. Groups 3 to 8, or 0, are known together as the P block. The inner transition metals are known together as the F block. When studying the ways that atoms bond to form different types of molecules, you can refer to electronegativity, the valencies of all the different groups as shown here, and other information. For now, I hope you have a better understanding of what is where on the periodic table.